Good morning, ladies and gentlemen. So, this particular video is going to focus, it's going to be the first of hopefully two videos, we'll see, of us kind of talking about something referred to as Ohm's Law. All right. And we're going to find out is that this is going to be the most important kind of rule that we use when we're trying to kind of look at a circuit, figure out what's going on. All right. But before we can kind of use this new law, we need to talk a little bit about what's going on in a circuit and kind of talk about some of the physical things that are happening. Now, the first thing I want you to do is this is your warm up. All right. Click the little link where it says circuit. You're going to go back to that circuit construction kit, which hopefully you've already played around with in the previous video. All right. And your warm up is very simple. I want you to build a circuit that basically has one battery and has two light bulbs that are both lit up. And I have the ability to turn it on and off. All right. Without cutting anything in the wires. So circuit, one battery, two light bulbs. I can turn them on and off at will. All right. So pause the video at this point. Take a couple minutes to put it together in your circuit construction kit, and then we'll come back and talk about it. All right, so you'll notice I've already got it kind of set up here, and actually I'm not even following my own rules. I only have one light bulb. But for this circuit, remember we have three things we have to have. So we need to make sure it's a complete circuit. We need to make sure that there is something in the circuit that's going to kind of use the energy we've given the electrons. In this case, it's the light bulbs. And we need to make sure there's something in the circuit that is kind of causing the electrons to move through it. That's kind of pushing them through the circuit, so to speak. All right, and that's what our battery does. So hopefully your circuit looks something like this. Now, what we're going to talk about today is exactly what kind of the three main things in a circuit are, the three main physical quantities we can measure in a circuit. So we're going to start with the three pieces we needed in the circuit. So we needed a battery, we needed a light bulb, and we needed some wires and a complete path. And what we're going to find out is that kind of each of these provides something important to the circuit to allow it to flow. So the first one we're going to talk about is the battery. All right. Now, the battery provides the push in the circuit. So it's the thing that's kind of pushing these electrons through the circuit and causes them to start moving. Now, in physics terms, that push is actually referred to as voltage. All right. So a battery, usually in our case, will provide voltage to the circuit. All right. Now, voltage is kind of a weird thing to think about when you listen to the definition. So for us, we're going to define voltage as basically, we can call it a potential difference in the circuit. Really doesn't mean much to us. That's kind of weird. It's a weird definition. What does potential difference mean? Honestly, what it does and what a battery does is it creates a charge difference between the sides of the battery. All right. And with this charge difference, what happens is that now one side of the battery is positive, one side of the battery is negative, and it causes the electrons to start flowing to the side that they're attracted to. All right. So in other words, we can say it's potential difference in the circuit, or we can say it's the charge difference between the sides of the battery. All right. And what this does, this charge difference kind of gives these electrons energy to move in the circuit. That's kind of the best way we can talk about it. So we can say it gives the battery, gives electrons, the best way to kind of say it is they give it potential energy to move in the circuit. All right. Now, for us, the most important thing we're going to see here, all right, is that we can kind of think of circuits a little bit like water flowing. All right. A circuit is basically a river of electrons. So we can kind of visualize it like a river of water. Now, the voltage would be kind of the equivalent of how high up a river is if it goes over a cliff and turns into a waterfall. All right. So if I have a really low voltage, it means my waterfall is not very high at all. All right. So they're not going to have, the electrons will not have a ton of energy when they're kind of moving through the circuit. Now, if we say instead, I switch it up and say it's a very high voltage, that means that it's starting up very high. So maybe in this case, it's starting up on the top of a very tall cliff. So the amount of energy, or potential energy the electrons could have is much higher. All right. That's the best way I can kind of describe voltage. It's something that's a little bit strange to think about first, and we'll kind of keep talking about it and keep practicing with it, but that's kind of our general definition. All right. Basically, all voltage is, it's the push that's getting the electrons to move through the circuit. All right. Now, for us, the ways that we can change the amount of voltage in a circuit is we can do a couple things. We can change the battery, because you'll probably know that different batteries have different voltages. If you've ever looked at it, you might see a number that says like 1.5 V or 9 V. All right. That's measuring the voltage. So we could replace the battery. And right now, that's kind of the only thing we can do. We're going to find out there's another way. There's another way we can do it when we talk about it in the next video about how we can actually affect the voltage. But for now, that's all that matters. Okay? Now, for voltage, the unit that we measured in is the volt. Amazing. All right? But voltage is the push in the circuit. That's the first thing you have to have. If your voltage is 0 in a circuit, it means there's nothing causing the electrons to have any energy, so they're not going to move at all through the system. Next, we talk about the light bulb. All right. Now, the battery provides the push in the circuit, basically. The light bulb, in this case, provides what we refer to as the resistance. Okay. And resistance in a circuit is pretty much what you expect it to be. The resistance is how easy or difficult it is for electrons to move through the circuit. So resistance, how easy or difficult it is for electrons to move through the circuit. All right? And that's literally a physical quantity. You can measure that based on looking at what is in the circuit. All right? Now, in fantasy land of physics that we live in right now, we assume that the only things that ever have resistance, that ever kind of make it hard for electrons to move through the circuit, are things like light bulbs or things that we call resistors. And literally, a resistor is exactly what it sounds like. It's just something that provides resistance in the circuit. All right? Wires in ideal land have no resistance. But in reality, anything in a circuit pretty much provides resistance. So wires provide some resistance. Light bulbs provide some resistance. Whatever else you put in your circuit provides some resistance. Okay? And the more resistance in a circuit, the harder it is for the electrons to move, so they will not move as quickly. All right? And we're going to find out is that that can affect what happens in the circuit. And the best way to think about that is, let's say, once again, we have our river, and it's trying to go over this cliff into a waterfall. All right? But let's say that in this case, at the very edge where the cliff is, a bunch of kind of wood, tree trunks, whatever, has gotten jammed up there. So there's only a tiny little gap for the water to go through. That would equate to there's something having a very high resistance. Okay? Which means in this case, the water can't flow very quickly because there's not a lot of space for it to flow through. The same idea kind of works for electrons. If the resistance is way too high for electrons, they're not going to be able to move very quickly through the circuit. So the best ways that we can kind of affect it is, honestly, there's two main ways we can affect it. We can either change the material the electrons move through. That's one. Or we're going to find out we can actually change the width of the wire. All right, and we're going to cover this in a bit more detail a little bit later on. It's referred to as something called resistivity. But basically, if you change the width of a wire, you can affect how easy it is for electrons to travel through it. Okay? Now, the last piece, so we've talked about voltage. That's the thing that kind of pushes the electrons through the circuit. Resistance, that's the thing that kind of stands in the way of the electrons and kind of governs how fast they can move. The final part kind of relates back to the wires. It is referred to as the current of the circuit. All right? Now, current is basically electricity. What the current is how much charge, it's how many electrons flow past a certain point in a certain amount of time. All right? So what it's basically measuring is how much charge is moving past me in a certain amount of time. All right? And if something has a high current, it's got a lot of current flowing through it, that means that it has a lot of electrons, a lot of electricity flowing through it at a certain point. And I do apologize. I'm going to go back to resistance real quick. The unit for resistance is the ohm, and that is actually, it's a weird little symbol. It is, oh, it's right there, shown by an omega. Okay, so that's the unit for resistance. I apologize. So for current, all current is just like we said, is how much charge flows past a certain point over a certain amount of time. And this would be the equivalent in our, going back to our water analogy, because it does a really great job explaining this. That would basically be the amount of water that passes me in a certain amount of time. Okay? And if I have a high current, that means I have a lot of water going by me in a certain amount of time, which can look like two different ways. It can either look like a lot of electrons moving kind of slowly, or it can look like a few electrons moving really quickly. All right? But in either case, those are both high current. Now, for us, the unit for current is going to be an ampere, or an amp. So ampere, amp, and the unit is just capital A. And once again, current is just measuring how much charge, how many electrons flow past a certain point in over a certain amount of time. All right. Now, for us, we're going to find that the easiest way to affect it is to either make the electrons move faster or move more electrons through a certain point. And what's rather interesting is that hopefully if you kind of paid attention to the first two pieces, you might start thinking about there's what we could do to actually cause the electrons to move faster or make it so that more electrons can move through a certain point. All right. Now, these three pieces of circuits, voltage, resistance, and current, all work together to govern how the circuit works. All right. And they come together to form a very specific rule. And once again, this is kind of our best analogy. The water itself is the current of the, if we're going back to this river going off a cliff, the water is the current, the width of the river is the resistance, and the height of the cliff is the voltage. All right. Now, these three things, resistance, current, and voltage, all come together to form one of the most important rules in electricity. And that's referred to as Ohm's law. All right. Now, for Ohm's law, what it does is we're going to say we're going to say Ohm's law governs how much current, how much electricity flows, depending on two other things in the circuit. So we'll start by saying the current, just writing out in words, is equal to two things. The current in the circuit, how much electricity is flowing, is dependent on how much voltage you push the electrons with, all right, divided by the resistance of the circuit. All right. Now, in symbolic terms, what it looks like is current. The symbol for current is an I equals V, the voltage, divided by R, the resistance. All right. But what this says is that basically the amount of electricity that's flowing in a circuit is dependent on how much I push the electrons, the voltage, and it's dependent on how much resistance is in the way of the electrons. All right. And if you think about it, it makes sense because if my voltage is high, if I'm pushing these electrons with a lot of voltage, the current, they're going to move pretty fast. I'm going to be able to move a lot of them. All right. So the current will increase. But if I increase the resistance, if I make it much more difficult for electrons to move through the circuit, we're going to find out that the current drops because it's not as easy for electrons to move. So that either not as many move through the circuit or they move much slower. All right. So right there, Ohm's law, most important rule in circuits and electricity. And what we're going to find out is that we can use it to look at different points of a circuit and figure out how much energy is being used. Okay. Now, this is going to be the end of this first video. We're going to stop here. The next video is going to work on kind of practicing using Ohm's law. All right. But with that being said, this is kind of the first, those are the three most important features of a circuit: current, voltage, and resistance. So with that being said, ladies and gentlemen, have a great rest of the day, and I will talk to you later.